Hello and welcome everybody to my presentation. Actually, let me just double check that we're good to go here. Okay. Present. Cool. Okay. All right. Welcome everybody. This talk is titled "Confidently Writing Your First Property-Based Test," and my name is Pachal. A little bit about me. That's what I look like because it's a better lit picture than my current video. And I've been working at PagerDuty doing Elixir there for about 4 years now. And I am based back and forth in the city of Toronto, which is in Canada. And we have a very active Elixir meetup there called Toronto Elixir Meetup. We also have a Toronto channel in Slack. So if you're based in Toronto or Canada or just want to attend our virtual meetups, please join our Toronto Elixir channel. Okay. One other thing I want to mention before I get going. So much of what I learned about property-based testing is from this book called Property-Based Testing with Proper, Erlang, and Elixir. If you're interested in what I'm saying here, or you want to learn more about property-based testing in general, I highly recommend getting this book. And I'm not in any way affiliated with Fred, but I really like his book. Okay, so property-based testing, what's the motivation? So this is some code I took from the Elixir enum module, the source code. At least it looked like this a couple months ago when I took the code. And here we have some tests, right? This is your classic example-based test, and we're testing the enum slice function. So the first couple of tests, they use a range. The next couple using a start and end index. We have negative indexes. You want to test all the things, right? But then don't forget that this enum module also deals with streams. So now we have to have a couple more examples that deal with streams. And then also don't forget your error cases. And this is a lot. I mean, obviously it's good. It's in the Elixir source code that we trust, but the motivation is can we do better? Like, can we kind of reduce some of these? I mean, a few of you can probably look at this and maybe think of some more tests or edge cases you like to test that aren't included here. Because with example-based testing, we can never test everything, right? You have to draw the line somewhere. And this talk, was originally titled "How to Confidently Delete Old Tests," yada, yada, yada. And I changed the name of the talk because this isn't really about deleting tests. That was the motivation for me and is what I did with this knowledge of property-based testing. But what I'm going to do instead is just teach you how to confidently write a property-based test, and you can decide how that fits into your code base, whether it be alongside existing tests or maybe replacing some existing tests. So here we go. The key word in both those titles, I guess, was the word confidence, because we want to be confident that whatever tests we're writing, whether they're property-based testing or regular example-based tests, are exercising our application code in a way that we're confident that the test provides value and that it's providing us some safeguards, that it's worth having this test in there. So you can't test anything without having a subject or application code to test. And the subject we're going to be looking at here is a library I made called Wild. And all it does is wildcard matching in Elixir, like the same as you would do on your operating system when you're looking through files and stuff like that. So there's some first two are simple examples. My subject is foobar, and then the pattern is foo star. So yeah, that matches. Second one, that matches as well. I also had a requirement that the module must deal with binaries, not just strings. So there's an example of that. There's an example of it not matching when it returns false, just to prove that it actually does return false. And then the bottom example shows just that this library can take some options. And these are options that I only learned about through property-based testing, and we'll get to those eventually. So throughout this talk, I'm going to be highlighting some confidence boosters or some tips you can take away with you, because you probably don't remember anything or everything, but hopefully if you remember anything, it will be these tips. And the first one is that when you're writing your first property-based test, you should definitely prefer to test purely functional code and hopefully simple functional code for the test subject. It's not harder to test stateful code, but for your first test, this is just an easy way to cut down on boilerplate. So that's my first tip for you. So what is a property? You might be asking. I mean, maybe some of you have done a little bit of this before. You've heard of property-based testing, but what a property is it's a rule that holds true regardless of the specific input. So for example-based tests, we tested with specific input and checked for specific output. Properties are a little bit different than that. So I'll put aside my wildcard matching library for a moment, just to look at this example of a cash register. And this cash register module has a purchase function. And this is the time before, this is paying in cash. So the amount, there's going to be an amount paid for some item price, and then we're going to get back some change. And change is going to be, like a list of dollar bills and stuff like that. So here's an example of that. This might be an example-based test where the amounts that the item costs is $14 or so. The amount paid is more than that. So we have some change that comes back. So we could restate this whole thing in a property saying that the amount paid in red should be equal to the item price plus all the numbers in green. That all has to add up or else you're losing money somewhere. So that can be our property. So when we have a property-based test, it looks much the same. We'll call our purchase function. We'll get back some change. And then we can write our assertion. And because the property doesn't care about the specific inputs, this assertion, this template, I guess you could call it, where the item price plus the sum of the change equals the amount paid, that should always be true no matter what inputs we generate for the item price and the amount that we paid. So here are some examples of that. Our property-based testing framework would generate something like this, where it would generate the red and the green, the red and the blue, because that's our inputs. And then we would test that our property holds true, which is that the item price plus the sum of the change will always equal out to the amount that we paid. There are other types of properties. I call those, I guess, classic properties. And and this is a different type called a symmetric property. And both of these code blocks are the same. It's just showing that we have some input. When I encode it and decode it, I expect to get the input back. This is something you might do, if you're writing a JSON encoder or decoder. You want to make sure that, whatever you get in, you can go round trip and get it back. That's what a symmetric property is. And then there's also modeling. So modeling is when you are basing your functionality off of some other functionality. So I might just generate some random arguments, and then I want to feed them into, some other code here, their code, feed it into my code, and make sure that the results are the same. And this is what I did for my wildcard matching library. Because I'm modeling an off of bash wildcard matching, I would generate a subject and a pattern, hand it into both implementations, and then make sure that they either both return true or both return false. Here's an example of how you set up some modeling. The summary of this screenshot is that we need to be able to call something from our X unit code, right? Which means it needs to be an Elixir. It's possible that your model might be some other Elixir module or Elixir function, in which case, great, that's really easy. In this case, I had to wrap something with a bash script, or I had a bash script, sorry, which just call it to my operating system to do some pattern matching. And then on the right, I just call that bash script in my Elixir code. So this just gave me something, I could use in Elixir. Here's an example of just the bash script. It's not that important, just prove that, that it does something. And here's the slightly more interesting example, just calling my Elixir wrapper around that bash script, where I can hand in a subject and a pattern and print out the results, and either doing that in IEX or just mix. Okay. So then there's also invariants, and invariants are when you have something, like it's not quite a property, but you have an attribute that is maybe tough to describe or tough to measure. And this example comes from that book that I referenced at the beginning, and it just says meal is good. And how would you write a property for that? And well, the answer is, well, it's hard to write one property, but what we can do instead is write 4 properties that act as kind of like red flags. So none of these properties on their own, if they were satisfied, would be good enough to say that the meal was good. But if any one of these is false, then we would know that the meal was not good. So if the food was not hot enough, or if the food was too salty or too sweet, then we could say, yeah, the meal wasn't good. So they kind of all work together to give you confidence in your system. And that leads to my second tip, is that picking properties is actually really hard. It's probably the hardest part of writing property-based tests. That's what other people say, and that's definitely my experience over the years. So definitely, if you can, you should prefer modeling or symmetric properties, because for modeling, your property is decided for you. It's just that this code should work exactly like that code. That's just what the property is. Similarly, for symmetric properties, you could say the property is that my input round trip should be the same as the output. And if you can't do either of those things, then hopefully you can pick some pretty simple properties to go forward with. Okay, so we talked about how property-based testing is all about properties that don't care about the specific inputs. So how do we generate those inputs? Well, property-based testing frameworks come with generators. They always come with some basic ones. So here are examples of integer, string, and Boolean. You can see it just gives examples, integers, strings, Booleans. And usually those aren't enough on their own. Usually you don't want to combine them together or constrain them in some way. So there I have some examples of just constraining the integer generator, just be 1 to 4, or the bottom example is always generating positive values, because I'm taking that integer generator, which can generate positive or negative, and mapping it through the absolute value function to make sure what I always get is positive. This is a good time to mention that there are two main property-based testing frameworks in Elixir. On the left is one called PropCheck, and that's a wrapper around a Erlang library called Proper. It's very good. I should say I use both of these all the time. They're both very good. On the one on the right, that is StreamData. It is much newer and written in Elixir. I don't have a strong preference between, I don't want to recommend one over the other because they both are good and they each have features the other one does not. But if you're just getting started with Elixir, I would say that it is better to go with StreamData. The only reason being that since PropCheck is based on Proper, you're dealing with binaries a lot. And usually at the end of the day in your Elixir code, you just want to deal with a simple string, and StreamData just has slightly better support for that. That being said, if you want to do stateful-based testing, which is not what this presentation is about, or testing stateful systems, PropCheck is better for that because, well, StreamData doesn't support it yet. And going forward, all my code examples are going to be based on StreamData. And here's what a test actually looks like, a property-based test. I guess I should back up a moment. So instead of using the keyword test or the macro test, we use property instead. You still give it a name. Then you have your generated input. So here I'm using the built-in binary generator for my subject and pattern. Then, because this is modeling, I'm going to pass that exact same subject and pattern to the bash implementation and to the wild implementation. And then I'm going to compare the results and hope that they're the same. And if they're not, print out some error message. And you still run it with mixed test. My one test run, you can see one property ran, and it worked. The end. Obviously, it's not the end. If you run the test again, you might find that you get different results. And that's because the input data that we're generating is not deterministic, it's random. So just because your tests run and pass one time doesn't mean they're going to run and pass the next time. So let's look at what a test failure presents itself as. So we have the name of the test, obviously, so you can go find what failed. I can see that in this case, the bash implementation, which is the model that I'm trying to mimic, returned true, but my code returned false. So I wanted it to have returned true. We talked about how property-based testing generates many examples for you. So in this case, we've actually done 42, random examples of subjects and patterns, and they all passed. And on this 43rd iteration, we got one that failed. And that failing code is the failing data is the subject was a binary with just the 0 byte, and the pattern was an empty string. This leads to my next tip, which is to keep your generators as simple as, or keep your generator simple with as few clauses as possible. And to explain why, let's look at a counterexample. So this is just some nonsensical property-based test. And the thing that I want to highlight here is just that there's a ton of clauses like A, B, C, D, all the way to G. And when this test fails, you get a lot more error, a lot more red. And it can be hard to determine which of these is actually important. Like, are you actually handing in 7 arguments to a function? Are some of these arguments combined to create another argument? Like, you can't really tell from this. So this is not good. And instead, what you should do is this. You can just take that generator or that clause and put it in its own generator called my generator, and then just call that. And now we can see that, oh, okay, these are actually used to create some sort of string. And now when your test fails, it will just say, hey, this is the string that was created. It didn't work. So let's do this instead of having many clauses in the test itself. Okay, so back to the test failure. 42 successful runs. You might be wondering, how many runs does a property-based test do? And that's actually configurable. So by default, StreamData will do 100 runs, which is a fine number, I guess. But the cool thing is that, yeah, it's configurable. So what is common and what I recommend you to do is to have more runs when you're on CI, or when you push your code to run on Travis or Circle CI, or in my case on GitHub Actions. That way we can do a lot more runs there when I'm not waiting around for them. And yeah, that's my next tip. You can configure for fast local development. So, just maybe do 10 or 100 iterations of each test locally. But then on CI, push it up to 1,000, 100,000, 1,000,000, whatever is appropriate. So that way it will take longer there, but be very thorough and be very fast locally. Cool. Okay. So after investigating the last failure, I learned some things, and I learned that the 0 byte is not very well defined on what it's supposed to do in pattern matching in Unix. So what what I'm doing instead is introducing a custom generator. So it's going to start by using the built-in generator, and then I'm going to filter out any inputs that have the 0 byte. So it's going to generate some binary. If it has a 0 byte, we're just going to throw that whole thing away and generate something new for my test function. And then for the test, I'm now using this custom binary one instead. Oh yeah, there's the filter. Cool. And I run it again, and it fails again. This time, the subject was a single byte, 158, and the pattern was a single byte, 1. So, this is you're going to go through these steps. You're going to make tweaks. You're going to run. You're going to find failures. You're going to do this loop over and over. And in this case, the loop actually led to new functionality for my library. After doing a little bit of research or bumping into more and more errors, I realized that I wasn't taking into account different ways you could be tokenizing things, which is exemplified kind of in the second code block here. If you take this string A, I don't know what the accent is called, but A with an accent, if you tokenize it as code points, you'll get 1 token. But if you tokenize it as bytes, you get 2 tokens. And this was causing, I was assuming one or the other, and it was causing my test to fail in certain cases. And of course, this tokenization is very important for a wildcard matching library. Imagine, or the case on the top shows, well, if I use a single question mark to match 1 token, that will work for code points, but not for bytes. So anyway, all this is to say that property-based testing showed me some new functionality that I wasn't even considering because I had made bad assumptions about my problem space. Which leads to my next tip. Test failures are often caused by bad assumptions. That's not to say that a bad assumption is not the same as a bug, because the distinction is maybe a little bit blurry. But oftentimes you'll find that it was just something you weren't considering, or it was some undefined behavior in your code that property-based testing has uncovered. So I'd encourage you, whenever a test does fail, to kind of dig into it a little bit and find out why that was the case. And maybe you'll find that you're making a bad assumption. Cool. Okay, so now we've been running for a while, tests are passing, everything is good. Except maybe it's not so good, because all we really know is that my implementation, this wild library, is returning the same as the bash implementation. And that's been working. We don't actually know what they're returning. Well, we know they should be returning true or false, but we don't know, what the breakdown that looks like at all. So it's probably worth looking at that breakdown. So here we're just going to inspect the result. And since the result is after the assertion, we'll know that it's the same. The bash result will be the same as the wild result. And this screenshot is pretty small, but the takeaway here is that, while there's a lot of falses there, we don't hit the true case very often. We're not exercising the matching part of our code base nearly as often as we're exercising the non-matching part. And that's not good because, well, A, we want to exercise all the paths through our code, but B, we would expect that users of this library are probably, going to hit the matching case. So we want to make sure that our input that we're generating is similar to the input that our end user might actually be giving us as well. You can dig in a little bit deeper. This is just a little helper thing that I wrote. I think it's just an agent or some stateful process that's just going to track all of these results and just spit us back some better. It's going to count it for us, basically, is all it's going to do. And actually, PropCheck has something like this built in. StreamData does not, so I just had to add a little wrapper. And when I run that, I can see, oh yeah, here it is summed up for me. 99% of the time, or really 99 times, it was false, and 1 time it was true. So that's not a very good breakdown. We would like to have more trues. And I went back and looked. Well, actually, I think it's the next slide. No. I went back and looked at what the true case was, and it just so happened that the generator generated an empty string for both the property, or not the property, the pattern and the subject, and 2 empty strings matched. And every other case didn't match. So we can take a look at those things and basically just what I just said. So here's just another run. In this case, none of these would have matched because we can see the subjects are on the left, the patterns are on the right. And yeah, it's not surprising that 2 completely random strings didn't happen to match. And this is kind of no good. So this is my next tip. You should definitely inspect the inputs that you're generating and the outputs to make sure that they're balanced and realistic. So balance in our case means that we have a good balance. We're trying to mimic what a user might actually do, and chances are more often than 1% they're going to hand through a matching pattern. And realistic, in this case, that one doesn't apply as much because wildcards can really be anything. But if you have a function that's supposed to take in some English text, then using the built-in string generator that's going to generate strings like this isn't very realistic because this isn't too much like English. Okay, so how do we move forward from here? Well, the first step that we can do is we can just create a new file, a new module really, just to put our generators in. This is good because it'll help us keep our code clean, and we can also exercise these separately, which I'll show off in a second here. But the main improvement that we're making here is that we're going to generate a subject still, and that can still be completely random. But now when we generate our pattern, we're going to give it a reference to that subject so that it can, however the generator is going to look, is going to hopefully generate patterns that will match the subjects more often. We're not going to look at the code, and that's really not important. This is just one strategy you can use, or just to show that you don't have to generate a bunch of independent data. You can tie things together in different ways. And now down in my actual test, I'm just going to use that generator function instead of defining the generator. Sorry, let me rewind that. I'm just going to call my new generator subject pattern gen in the test instead of generating the subject and pattern individually in the test. Cool. So now that we have our new generator module, we can actually just open up IX and test it out like any other module. In my case, I have to add on the mixenv equals test because this module just lives in the test code and isn't available like in dev mode. So we drop into IX. I call my function. StreamData, you may have guessed from the name, based on streams. So calling just my generators dot subject and pattern will return a stream. To materialize that, we can just pipe to the enum function, and then we can actually see some results. And all these ones with arrows are now actually patterns on the right that would match the subjects on the left. So finally, we're getting somewhere. And then we run it. Sure enough, we have confirmation that now we're almost at 50-50 between false and true. So we're exercising both code paths much more evenly, which is how we would expect our library to be used. And this took a couple iterations. I had to tweak some different things. It wasn't instant, but this is what you kind of should strive for. And that's confidence booster number 7, that you should treat your generators as first-class citizens, because the value, or so much of the value of property-based testing, is based on the inputs, and the inputs are not hard-coded like they are example-based tests. Our properties are essentially templates. It's so important to make sure that the inputs you're generating are good. So treating your generators, which are the things generating your input, treating those as first-class citizens is very important. This is not related to any tip, but these are just kind of interesting bugs that the property-based tests discovered as I was going through making my wildcard matching library. I don't recall what they all were, but I noted them down at the time with different comments. The takeaway just from this slide is that there are certainly things here where if I was writing example-based tests, I would not have come up with. Whether it's the low value bytes, I just probably wouldn't even have thought of that because I don't bump into that very often. Or the very bottom example, or having a wildcard class with just an exclamation mark, I just wouldn't have thought to do that. So it's really cool that the property-based testing, or more specifically the generators, came up with these inputs. So is this the end? Are we finally at the end now? And the answer is still no, but kind of. So I think for this library, I had set up nightly test runs, and it had been passing for weeks or months. And then finally, because it's not deterministic, it came back with another error one day. So it's kind of never done. I will be investigating this error whenever I get time, because like I said, I want to make sure I don't have a bad assumption in there somewhere. But the job is kind of never done. So don't be surprised if you do see failures after things have been working for a very long time. So in summary, for your first property-based test, definitely go for something that's simple and purely functional as your test subject. Picking properties is hard, so if you can avoid that by doing modeling of symmetric properties, definitely go for that. Keep your generators simple, configure well so that your local development can still be fast and you don't annoy the developers on your team, but that you can actually catch things in CI. Test failures are caused by bad assumptions. Yes, that's definitely true. 6 and 7 are kind of the same, but treat your generators as first-class citizens. Make sure you're looking at the values they're actually generating, and then also look at the values that the function that you're testing is actually returning. Thanks. That's all I have, and I think now we have time for some questions. Okay, looks like the first question is from Nathan. When you get a failing example, how do you ensure you rerun with the same data to verify you fixed the bug? That's a really good question. I would say that one thing you can do is just to, again, literally put some IO and spec statements in to make sure that something like that exact input or something similar is coming out. It would depend on what the failing example was, I guess. If it's something very, very specific, you could also add a single example-based test for that, kind of a regression test. Additionally, if you do use PropCheck, the other library, it actually caches failing examples in some capacity. I believe that if you run a mixed test, you get a failing test, you try to make some change, you run mixed test again, I believe that the failing test will be the first one tried again, which is pretty cool. Let's see here. Looks like there's no question from Justin. My org relies heavily on the example-based testing method. Do you have any advice for convincing them that shifting towards property-based testing is worth it? That's a good question. I would say that my company also, the code editor company or the test is probably still 99% example-based test. It's really started with me and a few other people that have just put a couple property-based tests here and there to start with, which was kind of the inspiration for this talk, is that it can be hard to go into an existing code base, that is huge, and try to figure out where to put your first property-based tests. So if you can find, a module that's just purely functional, maybe start by putting a test there and showing that to folks and maybe finding a bug with that. Another cool thing you can do, something that I've done a little bit of, is kind of go on a property-based testing, like treasure hunt or bounty hunt, where I just go into some library or some repo in my company or some open source library and just write some property-based tests to see if I can find a bug. I have found a couple, which is kind of fun to present that to the maintainer. So maybe something like that to show off the power of property-based testing is worth it as well. Oh, yes. John has a good comment, actually, for the first question of Nathan's. Right. So every time you run mixed tests, there is a random seed, and you can specify that with _seed. And because that random seed is used in the generators, you would generate the same input as you did the previous time that seed was used. That's also a good method. I actually didn't think of that, but that's really clever. Richard says, how would you compare property-based testing against testing that makes heavy use of test factories to generate values for inputs? That's a really good question. One distinction that I actually did not touch on at all here is something called shrinking, because it kind of wasn't the focus of the talk. But what shrinking does, and that's a feature of property-based testing, is that it might imagine you have a function that takes a string, and you generate some huge string that causes your assertion to fail. The property-based testing framework will kind of walk that string back to shrink the example down to the smallest failing example it can get. So even if your example was, some huge string, maybe it turns out that somewhere in that string was like, I don't know, a Korean character, and that caused your function to fail. And hopefully shrinking would drill it down to just that and say, hey, if you give a string with just this Korean character, your function doesn't work. So that's at least one example of where property-based testing is better than just using factories, because it will walk it backwards with shrinking. Cool. Well, if that's it, thanks so much, everyone. I mean, you can reach out. I don't have Twitter or anything. If you're on the ElixirLang Slack, you can find me there. There's also a testing channel that gets a little bit of traction. We talk about property-based testing there a little bit. So if you have more questions in the future, please come find me there. And thank you very much.